Hello, people. This is the first part of 2.4, solving equations with variables on both sides. Go ahead and pause and copy this down. This is going to be a really helpful page for you in your notes. If I were you, I would maybe dog-ear this page or put a big star on it or highlight it or do something so that you could return to it frequently. This gives you a nice list of steps in order to solve equations. So step one is to use the distributive property to remove grouping symbols, properties of equality to clear decimals, and fractions. And then you combine like terms, and then use properties of equality to get the variable terms on one side of the equation and constants on the other. That's the new thing that we're going over today. Step four, use properties of equality to solve for the variable. That's kind of undoing order of operations like we talked about. Step five is you could always check your solution. So let's see how this plays out. But first, when you see it, that makes for a bad day. All right, so here, solving an equation with variables on both sides. Miss Estenfelder, a former assistant principal here at Camp Ernst, used to always have this little like rah-rah siskumba cheer that she would say. In which she would say, variables on the left, numbers on the right, sit down, stand up, and fight, and be quiet, or so. I don't know. So anyway, I have variable on the right side of the equal sign and a variable on the left side of the equal sign. But if you recall, a solution is going to have a variable that's just by itself. We isolate this variable. So in order to do this, we got to get the variable on the other side. It doesn't matter really which one. I usually go for the one that's on the right, and that's what I subtract away. Now, if I subtract 2x from this side, my properties of equality say that I have to also subtract 2x from this side. Even though I don't know what x is, this still maintains the integrity of the equal sign. As long as I'm subtracting the same value from both sides, I'm good to go. These subtract out. This leaves me with 3x. And everything else just comes down. Now we get a two-step equation, which these you guys should be experts on by now. So 3x equals 12. Divide both sides by 3. Those simplify, and I'm left with x equals 4. Now for the sake of time, I'm not going to do this. Actually, I will, just this one time. You should always substitute these back in and see if they work. So I want to know, does 5 times 4, instead of x I write 4, plus 2, I want to know, does that equal 2 times 4 plus 14? Well, 5 times 4 is 20, and then plus 2 equals 8 plus 14. Well, 20 plus 2 is 22. And 8 plus 14 is 22, and ta-da. In my opinion, you should never ever get these kind of problems wrong because you could always check your solution. So I encourage you to do that. Please make sure that you are doing that. Here is one for you to try, so go ahead and pause and try that. All right, so here is what I got. So go ahead and compare yours to mine, and hopefully you got the same thing. All right, so solve an equation with grouping symbols. You cannot do anything with these variables as long as they are inside these parentheses, so we have to get rid of those things. And I always say that silly story about them being in jail, and everybody knows the best way to break somebody out of jail. You throw rainbows in the window. So we're going to throw around a bunch of rainbows. The rainbows mean multiply. So 2 times 5x is 10x. 2 times negative 1 is negative 2. Over here, 3 times x is 3x, plus 3 times 11, which is 33. Now we have the equation that looks like what we were just looking at a moment ago. So I subtract 3x from both sides, and I get 7x minus 2 equals 33. Add 2. 7x equals 35. Divide by 7. X equals 5. All right, I'm not going to go through the check on this, but I encourage you to do that. over here in this space, just so that you get into the habit of doing that. So here's one for you to try. Go ahead and take a moment and try that, and then check your answer against mine. All right, so here's what I got. Hopefully you got the same thing. I'm working out these problems so that you could see kind of how the steps go. So, I mean, you may not have exactly the same thing, but as long as you are getting to that, because there are a couple different orders that you could solve this in. But, if you're getting to this, then I feel pretty good. If you're not sure of it, though, make sure you ask me when you get to class. All right, what happens with these identity equations? So, I see some parentheses, so let's go ahead and get rid of these. So I'm going to have 2 times 5x is 10x, 2 times 6 is 12, and I end up getting something like this, where I get 10x plus 12 equals 10x plus 12. And I could go through and solve all this, and what you end up getting is that 0 equals 0. Anytime that happens, or if I subtract this 10x, I get 12 equals 12. Anytime you get the exact same thing equaling the exact same thing, that is called an identity equation. And what that means is that all real numbers will make that true. Any number that you put into this that's a real number, it could be 3, it could be negative 3/2, it could be any irrational number that you pick, is going to make this equation a true statement. So we call those identity equations, and the answers would be all real numbers. On the flip side of that, you have these no solution equations. So let's take a look at this. So I'm going to solve this. If I'm following those steps that I had on that first thing, remember step 1 is to combine like terms. So, or get rid of parentheses. If there's not any of those, I go down to combine like terms. So here I have an m and I have another m, so I need to combine those. So I get 9m minus 4 equals 9m plus 5. We'll subtract 9m from both sides. And you end up getting negative 4 equals 5. And that is not a true statement. So anytime that happens, that means that there is no solution. And you just write as your solution, whoopsie. You just write as your solution, no solution. And that's the answer right here. This is not the answer. This is the answer. All right, anytime that does happen, you want to make sure you go back and check. But remember, if they do not equal each other, then it's no solution. If they do equal each other, like this, then that is all real numbers. And that is it for today. Another short lesson, so I'll see you in class. Have a good evening.